Hello everyone. Hello everyone. Uh, this is Vamsi, having 6 years of experience in Amazon Web Services. Today I'll be taking a session on hands-on session on core Amazon Web Services. In the screen, we can see that this is the Amazon Console, Amazon Management Console web page. And here in Amazon, we'll be having regions which are different geographic locations where our Amazon is present. As of now, I'm in Northern California region. You can see here, this is where all the regions are located. And we have got North Virginia, Ohio, and Northern California, Oregon in US. So I'm starting Northern Virginia. And today I'll be starting with VPC, Virtual Private Cloud. Those who have attended my previous session, for a recap, Virtual Private Cloud VPC is nothing but a virtual data center in the cloud, in Amazon Cloud, where we can configure our own set of IPs, and we can configure our own set of rules, like what services should be in public and what services should be in private, and who should access what services and who should not access what services. So here, first, let's go to VPC. So please feel free to stop me if you got any doubts. So this is the default page of this is the landing page of VPC. Here we got a button launch VPC wizard. Using VPC wizard, we can launch VPC with single subnet, public subnet, VPC with public and private subnet, VPC with public private subnets and hardware VPN, VPC with private subnet only and hardware VPN access. Here hardware VPN access means it will be connecting from our traditional data center to Amazon Cloud. VPN access from data center to Amazon Cloud. But since this is a basic course, it is beyond to tell cover all this. So I'll be starting with creating a VPC manually. Here, if you go to your VPCs, Amazon by default provides VPC for every region. We can see it is default VPC. Default VPC, yes. So so now let's create our own VPC using Create VPC tab. And in the name tag, we can give any name which we want. So for the naming purpose, let's keep evoke VPC. And IPv4 CIDR block. IPv4 CIDR block means where we'll be, like I said in the previous, like we can give our own set of IPs. Here is where we have to give our set of IPs where our Amazon, our evoke VPC will be using. And here for testing purpose, for the session purpose, I'll be giving 10.0.0.0/16. And for creating a VPC, the maximum we can use is /16, which will be around 65,000 IPs, and the minimum is /28, which will be around 4 IPs, which will be only 4 IPs. So I don't want any IPv6 CIDR block, so I'm setting no. The tenancy is default. Here we can use default or dedicated. Dedicated means we won't be sharing any of our hardware resources with any other one, but it will be charging us a fortune. So let's use default and create. That's it. Our VPC has been created. But to access our VPC, first we would need an internet gateway for the public traffic to communicate with our VPC. So let's create an internet gateway here. Create internet gateway. Let's give a name as my internet gateway. Create. But this is in detached state, as you can see. So we have to attach it to our VPC. Here by default it will be showing only our VPC because that is the only available VPC without any internet gateway attached. and attach it. We can attach only one internet gateway with a VPC. We can attach 2 to 3 internet gateways with one VPC. It is like it should be one VPC with one internet gateway. And after this, now we have created VPC and internet gateway for the traffic to come. But again, for the traffic, where does it go after creating after entering a VPC? So for that, we need to create a subnets, public subnet and private subnet. Public subnet and private subnet are nothing but if you want our services to be accessible by public, we can place them in public subnet. And if we want, there will be few services like database where we want them to be, we want them not to be accessible by anyone from outside. So for that we can place our database in private subnet. So let's create a public subnet and private subnet here. So first create a subnet. Let's give us a name like public subnet, and here we have to set our VPC, evoke VPC, and this is the total CIDR range, and we have to select in from 10.0.0.0/16, and in the availability zone, let's select US East to West 1A. Here I have to tell you that a subnet can span across only one availability zone, which means that we can't have our subnet span in, we can't set up a subnet spanning across two availability zones. It should be either 1A or 1B. So here I'm selecting US West 1A, and the CRDR block range I'm giving is 10.0.0.1.0/24 and create. In the same way, let's create one more subnet and name it as private subnet. Select our default VPC or evoke VPC, and now let's put it in another availability zone. And here for this 10.0.2.0/24. So now we have created a public subnet and private subnet. We know that these are public subnet and private subnet, but how does traffic knows what is public and what is private? So for that, initially whenever traffic is passing through internet gateway, first it will be entering into route table or router. Router is something like it will be diverting traffic based on the rules configured in the route table. So for the traffic to be passing from the internet gateway, let's make sure that let's create a route in the route table to pass it to public subnet. So here we will be having a route created by default when we create a VPC, but I don't want I don't want this route table to have public access, which will be exposed. So let's create a new route, and let's add a new route and then use the route table. So in the name tag, let's name this route to internet, and VPC, select our VPC and create. We have created a route table, and first we have to add a route from the internet to our internet gateway. And the target is internet gateway, and here we got our internet gateway available, and save. So now what we did is from internet gateway the traffic will be coming to route table. So from route table we have to pass it to public subnet. So for that we need to make an entry in a subnet. We need to associate our public subnet with this route table. That is what we are doing here. Edit subnet, and here set the public subnet, save. So if you can see our public subnet public subnet is attached with this route to internet, and this private subnet isn't attached with any of the route table here. That means that we won't be having any traffic entering into this private subnet. So now we have created a VPC, we have created two subnets, public subnet, private subnet. We have created an internet gateway for the traffic to be passed, and also route table, a route in the route table for the traffic to be passed into public subnet. And along with the VPC, we will be having a network access control list. Network access control list will be automatically created when you create a VPC. And also a security group. So VPC ID is 84. So this is our security group created with our VPC we created. The main difference between a security group and network access control list is, say for example, you are getting lots of traffic from a particular IP. That could be he might be trying to hack us or do some DDoS attack. So for that reason, we might want to block a particular IP to not to access our services. So then using network access control list, we can block a particular IP. I'll show you how here. And inbound rules, edit inbound rule, and add a rule. So, and these rules are incremental. So let's add 200. So what kind of traffic? HTTP and port 80, and here we can give the IP which we want to block, like 10.10.10./32, and here deny, and that's it. We can block traffic from all the traffic from the particular IP. But in security groups, we can't block a particular IP from accessing our services. And one more thing is, network access control lists are stateless, and security groups are stateful. Here, the concept stateless and stateful means, say for example, like I shown you, if you add an entry in the inbound rule, then the traffic will be able to only come in, but can't go out since there is no entry in the outbound rule. So which means that if you are given inbound rule, only incoming will be there. Since there is no outbound rule, the traffic won't be taking the response, and it won't be going out. So that is called stateless. Whereas in security group, you can just give inbound rule, like add traffic, and if, say for example, you want to allow SSH traffic only from my IP, and then what happens is, even not only the incoming traffic, even the outgoing traffic also be happening, because these are stateful, which means that from this particular IP, all the incoming will be allowed because we added an inbound rule. At the same time, outbound will be also be happening since we added entry inbound rule. That is the difference between stateless and stateful. So with this, we have created a new VPC and two subnets, public subnet, private subnet. We have added a route table to route the traffic, all the internet traffic to public subnet. So this is what the basics about VPC. So now let's move on to creation of EC2 instance. Before continuing, any doubts? Okay. So next, go to EC2 compute service. So here I got 0 running instances. And these are created earlier, and these are terminated in state right now. So let's launch an instance. For training purpose, let's select Ubuntu 16.04, and these are instance type. Like if you can see, we got virtual CPUs and memories. So based on the virtual CPUs and memories, the instance families and the types will be changing. So if you want one virtual CPU and one GB of RAM, it is T2 micro, and this general purpose instance type. So if you scroll down, you can see compute optimized, GPU instance, memory optimized, storage optimized, etc. So based on your user requirement, you can choose the instance. So if you say, for example, if you have an application which is memory intensive, then you can use memory optimized instance. Or else you got a graphical purpose, you are using an instance for graphical purpose, then you can use GPU instance. Or else it's just a small database or small web server, general purpose would be suffice. Since it is training, I'll be taking the minimal one virtual CPU and 1 GB of RAM, and next configure instance details. So here we will be selecting the VPC which we just created, and the subnet will be public subnet. And since we want a public IP to be assigned with this to the subnet, let's enable this. And next, add storage. Here the minimum is 8 GB. This is basically a elastic block store, which is like a block based storage, where our OS files and everything will be stored. And here for this particular general purpose, the minimum is 8 GB. And we got provisioned IOPS and magnetic standard along with general purpose as well. Here the provisioned IOPS means, say for example, you are using an Oracle database or any database in this EC2 instance. Then if you choose provisioned IOPS SSD, then the input output operations per second between EC2 instance and ABS volumes will be more. Since it is a training, I'll be selecting general purpose SSD. And if you want these to be encrypted, we can use KMS values, which is beyond the scope. And if you want, we can add a few more volumes based on our requirement. If you want 2 mount points or 3 mount points, you can use this. Right now I don't want, so I'm not selecting this. Next, add tags. Here I would insist to add tags so that we can track who has created what time and who for what purpose it has been created. So name, evoke public instance. So next, go to security groups. Here we can either select an existing security group or the default existing security group, or we can create a new security group. Let us create a new security group and name it as my new SG. And here I'll be giving SSH access only to my IP and HTTP access to anyone in this world. And this is like a review page where we need to confirm and we need to recheck what all we have selected, everything, and launch. And this is a key pair page where basically Amazon won't prefer us logging won't prefer providing us a password every time. Instead, it will be providing us with a private key, and it will be storing the public key with the instance itself. So only whenever the public and private key matches, then only we will be able to access that particular server. So here let create a new key pair, and I'll be selecting as evoke key pair California Cali. We have to download this and launch. So now this is in public, so we got a public IP since it is in public subnet. Let's launch one more instance in a private subnet and see if we will be getting any private IP or if we will be getting any public IP or not. And this is the Amazon Machine Image page. Amazon Machine Image AMI is nothing but what kind of OS you are using and what kind of softwares like Python, if you want to use Python, if you want to use .NET or anything, whatever, what all softwares you require on your server, we can select here. If you can see here, we got Red Hat, if we got SUSE Linux, Ubuntu server, and I'll be selecting Ubuntu 16.04, and I'll be T2 Micro, and here it's our Evoke VPC, and this will be a private subnet. And if you can see auto assign public IP, it is disabled. Add storage, add tags. Private instance. Configure security groups. Let's select the same security group. Review and launch. Select the same key pair. Launch instance. So our public subnet instance is available with the public IP, and let's see the private IP. We haven't got any public IP available since it is in a private subnet, and we have disabled the internet access to the private subnet. So we won't be having any public IP or any IP available, public IP available in the private instance or private subnet. So let's log in into this public subnet. I'll copy this IP. And here, since we are not using any username and password, we don't want this session IP, and for this we need to select SSH auth, and here we need to upload a .ppk file. Since but Amazon, it will be providing .pem file, so now we have to convert .pem file to .ppk file. For that we need to have puttigen. Load this with the, here select all files. So we have created evoke keypair Kali, open, okay, and save the private key. We can just ignore this and press yes, and evoke keypair Kali .ppk, save. We can close this. Now we have to browse and upload this particular .ppk file to this and just open. Yes. And here it will be asking a login. You login as for Ubuntu server, the username is Ubuntu. For Amazon AMI image, the username is EC2 user, and for CentOS. So since we are using Ubuntu server, let's use Ubuntu. Oh. Seems like I have entered a wrong username. You can see it has taken where we are directly logged into the server without any username and password. We got 7.7 GB of root storage. If we want, we can increase the root volume, but for that we need to stop that instance, detach it volume. I'll show you. So let's go to this and let's stop this instance. But if we stop and start this instance, the IP will be changing. So if you want to add the same IP to remain, you can just go to elastic IPs create a new address, allocate, and now we have to attach this to our EC2 instance. So associate address instance, by default it is a public instance, and associate. So the particular public API earlier which we got from Amazon will be released to Amazon pool. So if you can see, this is the Elastic API which we have which we got allocated. So now let's stop the instance. Stop. Go to volumes. Select evoke public instance. We can see it is of 8 GB. So detach the volume. Before this, we have to see which region is it. It's in US to S1A, and the mount point is XVDA. So we have to keep in mind that. And now let's detach the volume. Once we detach the volume, it will be in available state like this. Yeah, so we have detached it. So now create a snapshot. Name it as root volume modification. Go to snapshots. So now the size of the snapshot is 8 GB. Here we can see the progress. Let's wait until the progress is at 100% and the snapshot to be created. If you can see, now the progress is at 100%, so the snapshot is created. Now from this snapshot, let's create a volume with increased size. It's the same general purpose, but now let's select 30 GB and the same US West 1A and create volume. If we go to volumes and refresh it, a new volume with 30 GB has been created. So now it will be in available state. So now we have to attach it to the stopped instance. Attached volume. We will be having the public instance stop, and here we have to select /dev xvda attach. So now we can see it's in use. So let's go to the instances. Your public instance. Start. So here it is /dev/sda1. So again, let's go to volumes. Let's detach this. That is why I said we have to see the mount point. What is the mount point name which we have created earlier, which we have allocated earlier. Now if we can see this SDA1 /dev/SDA1, but we have given XVDA. So that is the reason why it is not taking. So let's delete volume. and create a new volume from the snapshot. Create volume 30 GB. US first one, yeah. Create volume. So go to volumes. Attach volume. SDA1. Attach. See, now it is getting started. So meanwhile, let's copy this. Close this session. Control V. Close. Yes. Ubuntu. We are logged in. So now let's give message. Now you can see it is at 30 gig. Earlier it was at 7.8 or something, but now it was at 30 gig. This is how we have to increase our root volume in case if you want to increase it in future. With this, I have we are completed with EC2 instance creation. So any doubts? Okay. So now let's go to S3 bucket. Let's create a new bucket. Here the bucket name should be unique. Unique means in the sense like that name should not be used by anyone else. Here if you can see, we could say that enter DNS compliant bucket name, which means that if you got a static website, and if you want to publish it, you can use S3 bucket as well. So for that purpose, Amazon says that S3 bucket name should be unique. Let's create a bucket like test bucket. It's Northern California, and let's try creating. So bucket name already exists. So let's create evoke 123 and create. It got created. Evoke 123. So let's go to this bucket and upload a file or something. It can be any file, any image file or anything. Just looking for any image or something. So okay, let's upload this. Open. So you can see it is in progress. If it is success, we'll be getting success. Yeah, we got success. If it is error, we'll be getting error. So by default, we will be having no access to this file which I created. Let's try accessing this. If you can see, we got access denied. It's because initially the bucket will be having only private access, no public access. So let's remove the bucket access. So here we can see everything is blocked. So edit it and untick it, save it. We have to press confirm. And if it is a single object, we have to select this actions, make public. So earlier we just got access denied, but now since it is a file, we got it downloaded. If it is a PDF, if it is a PDF file, we can view it online. Apart from this, if you want to give the permission to the whole bucket, we have to write a simple code. This is the ARN Amazon resource name for the S3 bucket, and we should give get bucket permission to this ARN if you want to provide access to the complete bucket. With this, I am done with the training session. So any doubts, please feel free to ask me. Thank you.